All right, let's talk about AI. But stick with me because we're not going to talk about it in the way you're probably used to. We're going to talk about physics, we're going to talk about cartoons, and we're going to talk about why the most powerful intelligence humanity has ever built might just be running on thin air. You know this moment, right? It's classic. Wile E. Coyote, chasing the Roadrunner, goes full speed right off a cliff. And for just a few perfect, glorious seconds, the laws of physics don't apply to him. His legs are churning, he's got all the momentum in the world, but he's got zero traction. And then he makes that fatal mistake. He looks down. And believe it or not, that cartoon is the single best metaphor for where we're at with generative AI today. We've built this incredible intelligence that can write beautiful poetry and complex code, but it has no actual contact with the real world. There is no floor beneath its feet. It's just spinning its legs over a massive canyon, and the craziest part is, it doesn't even have the ability to look down. So what's the big deal? What happens when this intelligence that's just running on air is given real-world jobs? What's actually waiting at the bottom of that canyon? Well, it turns out the consequences are already here. This is not some far-off sci-fi movie problem. It is happening right now. In 2023, a couple of lawyers got in serious trouble because their AI confidently just made up 6 legal cases, invented them out of whole cloth. The FDA has already flagged over 100 medical devices powered by AI that are making decisions that nobody can explain. You know, when a chatbot makes up a court case, it's a funny headline. We all have a laugh. But when it hallucinates a fatal diagnosis, that's the canyon. To really get what's going on here, we have to use the right words. We throw around the term hallucination all the time when we talk about AI, but that word is actually dangerously misleading. It makes the problem sound like a cute little glitch, a random one-time error. See, a hallucination is usually a big, obvious mistake. It's so weird that you can't help but notice it. The real problem, the much scarier problem, is something called drift. It's the slow, quiet, almost invisible slide away from reality. And here's the trap. When the errors are huge, we laugh them off. But when the errors are subtle, we start to trust it. And that's when it gets really, really dangerous. So why does it drift? It's because modern AI is basically a ghost. It's an intelligence that has no body. Think about a self-driving car. If it tries to drive through a wall, its sensors and cameras all scream, "Stop!" It hits a very real, very hard physical limit. But what stops a chatbot from just inventing a fact? Nothing. There are no sensors. There's no body. It has no way of knowing where it ends and the real world begins. It can float right through a wall and not even know the wall was ever there. And this shows the fundamental flaw in how we're trying to build AI safety right now. We think we can make it safer by just feeding it more and more facts. But what we're really doing is not teaching the ghost how to see the wall itself. We're just teaching it to memorize the layout of the room. So if you move a chair 1 inch to the left, the AI will walk right through it like a hologram. Why? Because it never learned what a chair actually is. It never stubbed its toe on one. So how on earth did we get here? How did we end up building these incredibly powerful yet completely disembodied ghosts? Well, the answer goes back about 50 years to a single fundamental decision we made about the very nature of information itself. Picture it, 1970. A computer scientist named Edgar Codd comes up with a truly brilliant idea. Data, he said, should be portable. It shouldn't be chained to a specific physical location on a specific machine. And that idea, it gave us everything. The internet, modern computing, the whole shebang. But it came with a hidden cost we're only now starting to understand. By making information portable, we made it ungrounded. We taught our machines that a piece of data's position is meaningless, and boy, did they learn that lesson well. And our current fix for this deep problem? It's a system with a big fancy name, Reinforcement Learning from Human Feedback, or RLHF. What it boils down to is an army of people literally clicking thumbs up or thumbs down buttons to tell the AI when it's right and when it's wrong. We have become the AI's only connection to reality. Think about that. The machine doesn't need us for electricity. It needs us to tell it what's true. But you can see the problem, right? This is totally unsustainable. We can't be the arbiters of truth for a system that's operating at a global scale 24/7. We're trying to fight entropy with clicks, and that's a battle we will always lose. So if throwing more data and more human feedback at the problem isn't the answer, then what is? And this is the crucial insight. You don't fix a ghost by writing better ghost code. You fix a ghost by giving it a body. Or, to put it another way, you build a floor for it to stand on, a real foundation that connects it to reality. Okay, so let's talk about what this floor actually looks like. The solution requires a huge shift in how we even think about information. We need to move away from trying to make perfect maps of reality and start forging keys that can actually engage with it. A map, when you think about it, is just a description of reality. And any description can be wrong, it can be out of date, it can drift away from the actual territory. But a key is different. A key doesn't describe the lock, it has to physically engage with the lock. It either fits and turns, or it doesn't. There's no in between, there's no drift, there's only a click or nothing. That's the conceptual leap we have to make. This key lock fit is a concept called grounding. Here's a great way to think about it: a guitar string. It only makes a clear, beautiful note because it's pinned down at 2 points. The vibration resonates between those fixed boundaries, and that creates a stable, standing wave. Grounding is about giving the AI those same kinds of fixed points, a connection to reality that it can resonate against, creating its own standing wave of truth. Okay, I know, that sounds great, but it's a little abstract. So how does this actually work in practice? How do you build a solid floor for something as slippery as pure information? Let's look at a really clear example. Imagine a digital verified doctor badge online. In our current ungrounded internet, you can just right-click, copy that badge from a hospital's website, and paste it onto some fake health blog. It looks exactly the same. It's a complete lie. Now imagine a new kind of system, a sort of digital chessboard, where position equals identity. On this board, that badge gets its meaning from the square it's on, the hospital's verified digital address. If you try to copy and paste that badge to a different square, poof, it just dissolves. It cannot exist outside of its grounded position. Thud. That's the sound of the AI hitting a real limit. It's the moment when physics, not a human opinion, becomes the final arbiter of truth. And that's the whole game right there. On a chessboard, a bishop can't move like a knight. It's not because it's against the rules and it'll get a penalty. No, the very geometry of the board makes it impossible. This floor doesn't just forbid the lie, it creates a reality where the lie is impossible to even construct in the first place. So, we're at this really incredible moment. These ideas for building a floor aren't just theories anymore. The work to actually build it has started. And that means we have this huge, once-in-a-generation opportunity to reshape our entire digital world. Now, some people might argue, wait, won't putting all these constraints on AI just stifle its creativity? But let's go back to the guitar one last time. Does that rigid grid of frets on the neck kill the music? Of course not. The frets are the very things that allow you to create clear, resonant notes instead of just random noise. Structure doesn't kill creativity, it is the instrument that enables it. And this floor, this is the instrument we need to build. If there's one thing you take away from all this, let it be this. This is not some philosophical debate about the future. This is a progress report on work that is being done right now. The foundations are being laid, the concrete is being poured for a new kind of grounded digital world. This is happening. And that leaves us with the most exciting question of all. For decades now, we've been building these ever more powerful systems on sand. We've been watching our Coyote run on thin air, just hoping, praying it never looks down. But now we have a way to build a solid foundation. So the question for all of us is no longer about the danger. It's about the opportunity. Once that floor is set, what incredible things are we finally going to be able to build on top of it?